Hello, let's write some Haskell. I'm working on this toy language called Lang, and it's effectively a pipeline of functions joined together. And I'm trying to augment it now by adding the ability to define new functions that can then be used in the pipeline. And I started doing this last week and didn't get super far with it. Um, it I got kind of caught up in trying to parse the new function syntax. So plan for today is to pick up on that, finish the parser, and hopefully implement actually calling functions. But let's see how far we get. So I will. So this is the failing test I got to last week. Actually, here we focus on here. We can go to the plan. I've now lost my chat. Hang on a second. I need to restore this. Let me go. What about chat? Let's move over here. Cool. Sorry about that. So I'm trying to write this markdown. Yeah, this thing. I'm trying to write functions which look a bit like this. So we have name of the function. We have parameters. This is interesting. So parameters it takes within the pipeline. And then we have the pipeline type. So in terms of the pipeline, it passed in some text input and it passes out some text output. So that's these texts. And then indented, we have the definition of this function. So that's what I'm trying to implement at the moment. And if we go back to spec, I've got this test which has got a very simple definition of a function, which is the name of the function, which is ID here, and the colon, and then no parameter list, because I'm trying to do simple steps. We got the input, the type of the input in the pipeline, type of the output in the pipeline, a new line, some indentation, the definition of the function, which is just calling UID, new line, an empty line, and then the pipeline itself. The pipeline itself is just calling ID. And this is not working, I think. Can I run the tests? It's failing to parse, so it expects to get this thing back again. So a program containing this list of functions and then this pipeline, but it's trimming up on the colon, and that's where I left it at the end of last week. So let's pick up from there and see if we can make this a bit better. If I look at the parser itself, we have the way the program works is it calls parse function, which is this thing, and then it gets its methods as it can, and then it calls parse pipeline. Probably missing an empty line actually. Parse pipeline, looking for pipe or a call. So actually this should be some V space. Oops. And then parsing the pipeline. I'll just import this. No, V space is not a thing. We can just say it's exactly one new line character. Should do for now. Okay, we don't actually want to include that. Oh. So I'm going to parse a function. I'm going to parse new line character, but skip over it. And then I'm going to parse a pipeline. Okay, I don't imagine that will have fixed everything, but we'll see if it breaks anything else, I guess. Yes, it's broken everything now. Oh, of course it breaks everything. Okay, so the other tests I have are for just pipelines, and they don't have leading new lines. And I've told it now to expect a list of functions which might be empty, and then a new line, and then a pipeline, and that's not working. So what I need to do is, oh, I've already added this character parsing in here anyway. So the way function works is it looks for, at the end, it's looking for a new line and then another one. I guess I'm saying if you have a function, there has to be at least one empty line after it. So this is the one that I think is not working in the test. I'm going to try exporting that. Well, I have already exported it. So in here, I'm using it directly anyway. Sorry, my idea to start today was to start by just calling parse program directly rather than calling the full parser. But that's not actually, that's already what I'm doing, so it's not a good starting point. Okay, so if we look at the output from this, let's bring it up again. It is saying, expected this thing. I don't think that's the case. I don't think actually parse function will try to program. But it's not just, it's not matching, it's not parsing it. It's saying it's got ID, it's got space, and then unexpected colon. I'm expecting quotes or the end of input or white space. So let's have a look and see what parser thinks it should be. So this says parser identifier, which is many alphanumeric characters. So that should match ID. Oops. Where it's called from? Here. Okay, we parse the identifier, then we match space. I believe that's 0 more spaces. Then we're looking for literal colon and then some more spaces. Okay, what I might do is, not that, I will comment out the rest of the lines. And I will comment out that, and then we'll just have a look at that. So the we need input and output types, pipes as they're called. So we'll have a void pipe, pipeline type, and I'll just put another one in, and then we want the pipeline itself, which can just be let's bracket this, it'll be call, and then it doesn't matter what it is. Call takes more arguments than that. We got here, it's so we've got the name of the thing that we're calling, and then the argument list as well. Okay, and then parse pipe is not used. But I'm just trying to see if we can get this bit to work. So I will comment that out as well. Yes, okay. And we still have one warning, which is choice is not redundant. Okay. We run the test. So it should only be reading the identifier and then the colon. Okay. The way that works, so you go function ID. It's not showing me the input string here. It's a bit annoying. But it's not stopping here, which is really interesting. So it's something after ID that was causing it to fail and backtrack somehow, I guess. So we can have a look at putting this back in, and then space, and then literally a string, which is an arrow and then some more space. So I'll put this back in again. I wonder if this choice was filling before. Okay, import choice. Next error. We're not using the input pipe, so it goes here. Okay, so run the tests again. Weirdly, it's filling on the next line. So it seems to be happy up to this and then the new line, which doesn't make sense to me. If I now parse the output type, height, and run that, it's still filling a UID. Expected end of it, input or white space. I mean, that would make sense if it worked. Okay, so we now will parse new line and the tab character. Just click on that. And now it fails right back at the beginning. Okay, I'm going to try making the input string shorter. So we're going to say, we're just going to, let's start with simple things, right? We'll just parse ID. This is now going to be just parsing identifier. Means we have to comment this out again. And these will be voids. And then we'll get rid of that. Okay, so input is ID and the output should not match, but it should at least parse it. Okay, let's bin that because it did not return. So there's something wrong with the parser. Calling parse program. Oh, I need to run that test in isolation because what this will try and do is parse everything as a function. So all of these other tests are going to get very confused, I think. I don't know why they're not terminating though, but I think that's probably what's causing it to not finish. Run a test in isolation. Sure, there must be a way of doing that, but I don't know what it is. Let's just comment them out. Like comment-driven development. Okay, still not finishing. So let's just put everything back to where it was. Let's try and do ID colon just so it can fail with things which are not functions. So back to here, we will parse this. I think this is optional white space. think it is. Okay, now parsed. So it expected ID void text in that call and in that pipeline. And actually what it gets is ID and the voids we're filling in by hand, and then an empty call because we haven't returned anything, and an empty pipeline because it's not getting any further than that. Okay, so let's try parsing the input type. So we'll import that again, and then we'll use the input pipe here. So does that take us a step closer? No, it does not work at all when we get to parsing the input pipe. Okay, I guess that's at least a clue. So it's looking for string void or text or time, and in the input, oops, we don't have anything. Right, with some input. Okay, now it did parse it properly, I guess. Still void, that's what we expected. Okay, so if we then put in void to text, and we will now try parsing the next two lines, the next two lines of code. So we should now have the input pipe, we should match the string, and we should match the output pipe. We should now return function, and then the identifier, which is ID, and then the input, which is void, and the output, which is text. That's what we're expecting, and then it should stop at that point. That's cool. So we get ID void text. Good. So now we don't match the next line, which is the definition of the function. Okay, can we now do this line? This is new line, tab character, and that's all for now. We're calling parse program instantly. I want to test with parse function, so maybe I'll come back to that in a second. Okay, still matching this, which is cool. But in here, I'm going to export parse function as well as parse program. And we will try calling parse function and import that. Okay, and the type of this is not program, it's just a function, single function. Okay, so we parse this input, and we should just get back the function without the pipeline bit. We run that. I get some stupid error. Okay, so it's parsing the function okay. We just add function body. So what we can do now is we can tell it to parse the function body. And this should just be the pipeline. And back in here where we're parsing the function. So a new line, we got the indentation, and we'll put the definition of the function and then two blank lines. Now we're getting a parser failure with empty line. Unexpected end of input, expecting new line or white space. Okay, so let me just go back to here. We parse the pipeline, ignore any space, and then we expect a new line character and then another new line character. So, oh, okay, so parse pipeline ends in end of file, and that's not what I want anymore. Right. It's not space I want, it's H space. Okay, so parse pipeline doesn't look for the end of the file, but parse program should look for it. Okay, if I would just rerun the tests, if I get rid of the unnecessary import, rerun the test. Okay, getting closer to the function parsers now, but some other test is failing to do new lines. Which is here. Right. So this says if there's space at the end or new lines at the end, then we consume them after the pipeline. And I don't want that in the parse pipeline function because that would then consume new lines which belong to the function syntax. But I probably do want it in the parse program. So here I'm saying parse program. We say end of file. Before that, we can say space. We'll just keep anything, any space at the end. Ooh, they all passed. Okay, cool. So the problem with parsing functions was actually inside parse pipeline because it was looking for an end of file. So parse function was always failing. Okay, so we can say it parses a function followed by a pipeline. The pipeline is like the sort of main function in this language. What we're going to say here is UID, and now expect it to be a program, so we need to parse the whole program, not just function. And this is now going to be a program consisting a list of functions, which is just that, and then pipeline, which is just called UID and then no arguments. And I need to import that. Okay, so it's like the thing above. Oops, we're actually going to call ID, not UID. We define a function and then we call it. That passed very quickly. Okay, and then can we parse multiple functions? Parses, oops, multiple functions. So what we say, we'll say input is that, I guess it doesn't matter what the actual function is, but we'll call it stupid, goes from void to void. And then the implementation of stupid will just be, stupid. Doesn't matter, it's just an identifier. And then we'll put 2 new lines in and call ID. I guess that's okay. Okay, so the implementation of this is a function. Sorry, not implementation, the thing that it should match is a function called stupid, which goes from void to void. And the implementation of this is called stupid with no arguments. Okay, let me just try running that. It works. Good. Okay, next one is it parses pipelines. Pipelines in the function body. And we'll just grab something like this. Okay, so for this one, instead of saying UID, actually we'll still start with UID, but we will then pipe this through stripping out dashes. I think we can do. Okay. So now the implementation, the body of this function should be called UID, but it shouldn't be that at all. It should actually be a pipe, where the first part of it is call that. Not pipe, hang on, let me go and look. The pipelines look like pipe. Okay, so pipe's got 2 arguments. It's got call on the left hand side, it's got another pipeline on the right hand side. So the right hand side, this is also call. And this should be strip. And it's got the argument of dash. Okay, so we now have a function with a more complicated body inside it. And that should work as well. Cool. Anything else I need to test here? So we can do multiple functions. I'm not going to look at parameters to functions yet. But we have some very basic functions. We can parse them. Can we evaluate them? So we have running stuff, we've got errors, and let's describe functions again. So we can start with something really simple, which is we can have a function which is really just an alias to another function, a built-in thing. So it evaluates very basic functions. What are we going to say here? So we're going to say run. We need the whole program. So actually, let's say let input is equal to, and the input is going to be a function called ID, which goes from void to text. And the implementation will just be UID. And then the body of the pipeline of this program will just be calling that function we just defined. And then we can say run input should be, I'm expecting this to work. So it should be right. And it should be a successful case, which is okay. And then what do they look like? Oh, it's just got some text. So the idea is something like 1, 2, 3, 4, 5, 6. I think that's how the built-in of UUID is currently implemented. If I run this, it fails because we got unrecognized function ID. Okay, so presumably we've got some functions, it just currently ignores them. Although I can't remember what I was doing last time, so we'll see. So we'll need to come back and do the type checking of functions. So here when we're doing type checking, we ignore the functions altogether. And in the evaluator, we're also ignoring the functions. So let me just do the evaluation without type checking it, and then we can come back and do the type checking of functions as well. And I guess we type check them in the pipeline. Okay, so functions, I've got this data type. So it's got input, output, and definition. So the definition I need to turn into this function signature somehow. What I'm thinking is we can take this list of functions and we can add to it. Sounds tricky. Oh, maybe it's not so bad. So we go, the functions are all defined first. So we can just loop through that, language. We can take that list of functions, and for each one, we can add to this. We can start from here and we can just add to it. So we're basically folding over the list of functions, starting from this list, and for each function, we'll add a new entry into it. That's what we're going to do inside eval. So down here, call built-in, we'll just look up in functions, but we're going to have to extend this a little bit so that we pass in a list of functions. And functions, what type of function? The map of text of functions. So we can say type functions is equal to map text function. We say functions has type functions. And down here inside eval, particularly called built-in, we can change this to say, given a list of functions, and the name of something, whatever else. So we just call this f's, and we look it up in f's, and then we'll explicitly pass this in, so we can pass in functions at this point. We haven't added our new ones in yet. I'm just going to run the existing test to make sure that only our new test case fails, and that's good. We haven't broken anything by doing that. So now, at this point, what we can do is we can say go, given some functions, and this, we can say functions. I'm going to call them fn's, but an f, make it a bit clearer. So pass functions in there, and then for the other cases, I don't know what I just did there. We will ignore functions there, and here, we will pass the functions in again when we are recursing. So now here I can just call this with functions. So we've still only got the built-ins. Run the test to make sure I haven't broken anything new. That's good, so only my new test case fails. Okay, so now I can replace this with the evaluated functions. So this is going to take some initial functions and it's going to return a new set of functions. And I think this is going to be a foldle and what we're going to do, there might actually be a built-in for this because we got, oh no, it's not, we don't have a built-in. Sorry, it'll be a foldle and this is going to be a function which goes from, it's going to go from a list of functions. This is not why I should put the type signature, but just thinking this through, we're going to go from functions to functions and then a definition. And it's going to return a new list of functions. Okay, which means that the initial value we pass into foldle will be, we can just say add function here. I'll work out what that is later. So foldle don't want either of these foldles. I want a different one because we're going to fold over a list of functions. Has it got option to import it from data.list? Maybe we'll scroll off. Data.list foldle. Sake. Import that qualified as L. Okay. So now L folder should be in scope. Cool. So it should be our list first. And then the functions, is that right? I think it is. List functions actually got an empty list. All this up. So Google foldle. You give it the initial value first, which is our functions, and you give it the list, which is our list of function definitions, and it should return a new list, which is the functions map. But a new, not a new list, new value B, which is the functions map. You give it B first, and then the list of things. Okay, and then add function. We're going to take functions, and it's going to take a function definition. So let me just go to the parser. Second, this is the type is fn. Comes out the parser, and it's going to return a new list of functions. We'll import that. Okay, and then add function. Now this has got the existing functions and it's got a new function definition. And what does that function definition look like? The keyword fn, there's a constructor fn that's got name of the function, input, the output, and the pipeline. A couple of these are easy. This has got name, input pipe, output pipe, and then the pipeline. And then we can say m.add. Not sure what's inside m. We want to say I want to create a line like this. But these evals are a little bit tricky. So this is my example, and also I'm going to grab an example of a function that we're actually calling. Okay, this is what I'm shooting for. So the thing that we're adding in here is the name of the function, and then we create a new function, and it's got input and output. And then it's got the definition. So this is something which takes a list of params, ignore, it takes an input, I'm going to ignore for a second. Oops. We're going to return pure of we kind of want a deferred evaluation here. I mean, okay is going to be a bit presumptive because it might not work. Let me just do nothing in here. What are we saying here? So text value, so we can just say void value. Okay, so I can put on that constructor. Okay, it's slightly closer. So this is the thing we want to add into our map. So here we just look up data.map. And I want to know what functions it has. Map. So some kind of insert. Use insert with. Insert. That's all I want. Sorry, so we say insert. We give it key value map, and it gives us back the new map. So here we can say insert in, sorry, the key is the name, the value is the function, and we insert it into there. This becomes m.insert, to open, to close. Why is it not like void value? Because that's not a thing. Can we say text value hi? Okay. So now we can take our definition of functions, function definitions. We'll pass that into here. Oops. We don't need to take this input because we can just assume that it's going to be functions, the built-ins. I might rename it to built-ins. And now instead of this, we can say eval functions. There we go, except we're not using the pipeline yet, and our definition of the function is incorrect. So this will be wrong, but it should still insert something with that name. Okay, I'm going to try running the test, see what happens. One failure. It still does not recognize the function ID. So it looks like it has not put ID into this map. So how do we debug this? There's a case this isn't right. There's unrecognized command name. I can just give it a map. So we just give it functions here. And show unrecognized command, given the name of the command and the functions will be unrecognized command, quote this, and then we'll say in. And can we show functions? Apparently we can. Okay, so our type function, oh no. Deriving equal. No. Oh, deriving stock. Those function signature. There's no show instance. Has it got an equal instance? No. Oh, goodness sake. Okay, that's right on derivation. Instance. Instance of equal for function. What's it missing? Equal, equals, okay. So that of sum a and b is equal to both functions. We can say function, what we look for. Actually, the function signatures we want to compare, but that's the hardest thing to do. What's type of equal? I'm trying to scroll in the pop-up, missing each time. Documentation, no. What's that? Type of equal, I think, is compare, which means that we should say there is a type constructor called EQ. No. Let me ask Google. Oh, it's AA bool. Okay. So that can just be true. Well, now it gives me the type. That's really helpful. We just say all functions are equal to other functions for now. Default would make a bit more sense. Okay, so now when we run the test, we should get, oh no. Where is this happening? 143 into 121. So here we can say functions, and 121 is in the pipe check. We can just give it an empty map for that. Oh, maybe it's the pipe checker that's failing actually, not the evaluation. Maybe the evaluation is fine. Notes for show function. I thought that was okay. Obviously not. Where's function? We have to write our own instance for that as well. I think we can't derive it. Deriving show. No, because function signature doesn't have show. And I don't think we can say deriving on a type. So let's write instant show function where show function is equal to, and we'll just print out the show function input pipe of fn, and we'll say what it maps to, which is show function output pipe of fn. Function result. Okay, can we run our test now? Okay, unrecognized function ID from empty list. Unrecognized function rubbish from the empty list. Right. I think this is coming from the type checker because the list is empty. So I guess we need to fix the type checker. So we got functions here. These are function definitions, and I check built-in needs to be given a list of functions, and it looks them up by name. Okay, I guess something to eval. So all of this, the eval functions is actually going to be building a list of functions. So let me just lift that there and put it here. It's not going to be eval functions. It's not a great name for it. We might call this something like map functions or build functions. Something to call it. Define functions. So nice is still going to. It still only takes. It doesn't need to take the list of built-in functions because we know what that is, but it does need to take a list of FDs, which is actually FN. Transat. So we call these things. Let's call them FNs here. And yes, I could reduce that. So we'll say where these things. This goes to here. The function is already used, so I was going to clash. So let's go back to calling this FDs. I'll give it a name. That makes life easier, doesn't it? Okay, so it's not eval functions, but it's now define functions, passing in the function definitions. Okay, and then that means I can call it from the pipe checker. So we can say go, and we'll pass in, as the pipeline, we'll pass in the functions. So here we should get functions, whatever that type is, I forget. And here we say fn, and we'll pass into checking the built-ins. And here give them some functions. Called go again with the functions. And here when we recurse, we'll pass in the functions. And here we take functions. And then here we can say functions at this point. And then we use it here. Okay. So now in theory, the pipe checker should also be able to look up a built-in function. Cool. Very cool. Okay, so this is failing because I changed the output from the unrecognized command. I might just put it back because that's just a debugging thing basically. And then it interpreter failed because I'm not defining the function properly. So quickly-ish, get rid of these instances and then see what breaks. down over here. I'll get rid of the functions here. I'll get rid of the functions here. And then I will get rid of it here. That was wrong anyway. And then here as well. Okay, rerun the test. I should get one failure, which is cool. Okay, so what I will need to do for the definition of the function is something. It's different from the built-in. So the built-in has got a Haskell function I call, and the function I'm defining will have a pipeline. So I'll need to work out how maybe separate those two into two different implementations of function, which means I might need a type class for something which is type checkable, and another type class for something which is evaluatable. But I'll come back to it next week. So I made some progress. I can now parse the functions properly, and I can put them into the list of functions. I just can't get the function body right at the moment. I'm not really doing I guess the type checking does work actually. Yeah, it's just the function body is not correct. So next week I'll come back and look at it again and see if I can get the function definition. Cool. Okay then. But for today I shall leave it there. I made some progress, which is good. So yeah, thanks for watching. Hopefully see you next week. Bye.